Okay, Assalamu alaikum everyone. I hope all of you can hear me and also see my screen. So can anyone please confirm that you can see the PDF that I'm sharing?
Yes.
Yes, sir.
Okay, great. Acha, so first of all, regarding the assignment on ggplot, that will be posted today and you'll have a week to do that. So that's a lot of time, should not be an issue. Today, what we want to do is we want to move on to the prediction part of our analytics journey. So remember where we started from. So in our very first class, if you remember, we saw a chart that looked like this. So we said we have, we may basically be dealing with three different types of analysis. We have descriptive analytics, we have predictive analytics, and we have prescriptive analytics. Anyone who would like to tell me what each of these things here means? What descriptive analytics means, what predictive analytics means, and what prescriptive analytics means, just as a review. Anyone?
Sir,
Yes, Azhar.
फिर existing data को readable और उसमें से insights generate करना would be descriptive. उसको एक model की shape देना जिससे हम forecast या future scenarios को थोड़ा बहुत predict कर सकें, that comes under predictive. और अगर हम
Right.
एक और उसकी future simulations वगैरह बना के आगे की चीज़ों को मतलब एक present करके एक decision लेना, that could be prescriptive.
Okay, great. So basically descriptive means that you are looking at your existing data, something that has happened in the past, and you want to describe what has happened. So you could use different tools for that. You could, for example, what we have covered in our course is data visualization using Excel, using ggplot. Uh, and we can also make different kinds of tables like cross tabulations, line charts and stuff like that. So that's all of that was basically to understand our data better and generate some sort of insights from that. The second step of this analytics journey is that once you have some insights from the data, what you want to do is you want to use your existing data to make some sort of to generate some sort of models that you can use to predict what would happen in the future. So that's called predictive analytics. So today we'll be moving to that part of our journey. And then finally, what happens is in prescriptive analytics, based on the different models that you have built, you basically make decisions based on that, and that's prescriptive analytics. So right now we are somewhere at this stage where we're dealing with forecasting, data mining, predictive modeling. So these three things that you have in the middle here. Acha, before I move on, since I'm using a PDF for the first time in Zoom here, can you see this hand moving, this cursor moving? So I know my point cursor.
Yes.
Yes, sir.
Yes, sir.
Okay, good. All right. So this is what we're going to be doing today. We're starting to discuss this predictive modeling, forecasting, etc. Right? That's part of predictive analytics. Now, what we're going to cover in this is basically machine learning models, right? And today is going to be just an overview of what machine learning means and what different types of methods are available and how we're going to be working with them. So I'm going to purposefully remain a bit vague today. So there are going to be many different details today that we're not going to spend too much time on. But as we move on in the next few classes, you will go through each of those details one by one, and you'll be able to understand them better. So today is mostly going to be an overview of what is going to be there in the next few classes, right? And also what machine learning means, where it stands in the whole analytics spectrum. So first of all, what is
Sir,
machine?
before we do that, एक question आपसे पूछना था.
Yes, sir.
सर हमने जो प्रेडिक्टिव जो मॉडलिंग की है स्प्रेडशीट में, हाउ डू वी टेस्ट कि ये इस मॉडल की लिमिटेशंस क्या हैं, मतलब कोई प्रोसीजर होता है फॉर्मल जिससे हम एग्जिस्टिंग मॉडल की लिमिटेशन को आइडेंटिफाई कर सकें?
हमने एक्सेल के अंदर एक तो प्रिडिक्टिव मॉडलिंग हमने उस तरह से जो है मतलब वी कैन नॉट रियली कॉल दैट प्रिडिक्टिव मॉडल इन अ सेंस बिकॉज वी नॉट प्रिडिक्टिंग एनीथिंग अनसर्टेन अबाउट द फ्यूचर। वो हम बेसिकली डिफरेंट जो है सिनेरियोस को डिस्कस कर रहे थे कि अच्छा इफ दिस हैपेंस this could be the output, if this happens this could be the output. This predictive modeling that we'll be discussing here, it's slightly different from that. To answer how we can test our assumptions there, उसमें what we can do is कि हम different assumptions की sensitivity measure कर सकते हैं कि वो आपका जो output है वो कितनी ज़्यादा sensitive होगी to certain assumptions. However, there's no set method in terms of identifying if you have missed any assumptions. That's going to be based on your own judgment. So, for example, when we were doing what if analysis, we also discussed कि आप different inputs को change करके देखते हैं, is your output reasonable or not. For example, in one of our examples, what we did was when we were changing our price, we were not really having any effect on our demand because of that. And when we actually ran some different what if analysis on that model, we figured that out कि अच्छा price को change करने से हमारा demand पे effect नहीं पड़ रहा. So that's an assumption that we have that we are using in that model that might be a limitation in a sense कि वो इतनी practical नहीं है, and we might want to consider a different model जहाँ पे हम उसका इफेक्ट कंसिडर कर रहे हो. बट दैट्स मोस्टली गोइंग टू बी योर ओन जजमेंट एंड नॉट देयर इज नो सेट प्रोसीजर फॉर दैट एज सच. यहाँ पे हम देखेंगे हमारे पास कुछ जो है वो एक तरह से आप क्वांटिटेटिव टर्म्स में मेजर कर सकते हैं कि आपकी जो प्रेडिक्शंस होंगी वो कितनी एक्यूरेट होंगी. अगेन यू स्टिल नॉट गोइंग टू गेट एग्जैक्टली कि आप क्या मिस कर रहे हैं बिकॉज देयर इज नो वे टू have a computer model tell you that, but what it can tell you is कि आप किन assumptions को use करके you're getting more accurate predictions और किन assumptions को use करके आपकी predictions उतनी ज़्यादा accurate नहीं आ रही. Does that make some sense, Azhar?
ओके.
Okay, so let's start with this, with machine learning. So let's first try to understand what it means. So a lot of machine learning is going to revolve around this thing, that you're going to have some variables. अब यहाँ पे don't get very confused with this complex thing that you're seeing here. But all this means is कि आपके पास ये x1 से लेकर XP that you have a lot of different variables. These are called your input variables, your independent variables. You are applying some function on that. So, and you get this Y as an output. So basically, a lot of machine learning, specifically supervised machine learning, and we'll discuss what that means as well. But that's basically most of what machine learning revolves around. It means कि आप कुछ इंडिपेंडेंट वेरिएबल्स में और एक डिपेंडेंट वेरिएबल में एक रिलेशनशिप जो है वो फाइंड करना चाहते हैं सो दैट यू एबल टू प्रिडिक्ट समथिंग about the future. Now it could be anything. So we have worked with some examples in the past. For example, we could, uh, for instance, predict salaries based on some explanatory variables. For example, if you were to think about somebody's salary, what different kinds of data points would you think कि वो helpful होंगे एक बंदे की salary जो है predict करने में. So most likely it's going to be education, it's going to be their experience, it might be the industry that they're working in, and there could be some other factors as well. जो practically they do have an effect. For example, ethnicity of a person, the nationality of a person. All of these things could have an effect on a person's salary. So all of these things will be considered independent variables, and your salary is going to be considered your output or your dependent variable. That's going to be the Y variable here. So the idea is we want to um, predict some sort of an output using some explanatory variables जो जिनको एक function जो है वो define कर रहा होगा. एक function आप independent variables के ऊपर apply करेंगे and that's going to give you some sort of an output. ठीक है, that's basically the whole purpose. Now what happens is in most of the cases आपके पास हो ये रहा होगा कि you have let's say for example let's stick to the same example. You want to predict salaries of fresh graduates in Lahore, for example. Now how could you go about it? So every year, for example, what number do you think, what number of people, what number of students do you think graduate out of university in the city of Lahore? Any guesses?
इसमें सर हम ऐसे करेंगे, अपने जो पास्ट डाटा है ना, हम वहां से देख लेंगे कि क्या पैटर्न चल रहा है, तो उसके
Okay,
लिहाज से
so,
हम गेस
okay, so
कर सकते हैं कि
let's start about it. Let's go about it step by step. So, what is the number of graduates that you think we have in Lahore every year? Any rough estimate?
10,000.
10,000. Is that a reasonable estimate? And anybody else?
Sir, maybe
5,000
one.
के करीब.
Um, okay. So if I were to tell you, LUMS alone produces about 1,200 graduates every year. And how many universities do you think there are in Lahore?
Is it
20,
40,000?
20.
Sorry?
50,000.
50,000 might be a bit too big. So okay, so let's assume somewhere in the middle. So somewhere in between 10,000 and 50,000. So let's say it's 25,000, right? Just a random guess. Not as random, but based on the number of universities, and let's say on average about 500, 600 graduates from a university. So let's say it's about 25,000. Now, of course, if you want to build a prediction model for their salaries, you cannot really go around and ask every person कि उनकी salary क्या थी and get that data, and based on that build that prediction model. What would usually happen is that you would get a random sample. Let's say you get access to 500 or 1,000 students who have graduated recently. You get their salary information, and based on that, you build some sort of a model. Now, I'm not going to go into the details of the model itself because there are many different possibilities. लेकिन idea ये है कि उनकी आप information लेते हैं that we just discussed, कि उनकी education क्या थी, उनकी field of study क्या थी. Since they are fresh graduates, of course, they don't have any experience as such, but we could have data on their internships, we could have data on their academic performance and things like that. And based on that, we also have their salary information, और हम एक model build कर सकते हैं उनको relate करने के लिए कि किस तरह से वो independent variables जो है relate करते हैं with the salary, right? So that's what the idea is. And then what we want to do is we want to say, if we have a new person whose salary we do not know, what we can do is we can get the information, like again जो उनका GPA, for example, जो भी हमने information use की है to build this model, we can get that information. For example, उनकी किस university से वो पढ़े हुए हैं, what is their field of study, and their academic performance, etc. And we can use that to predict their salary based on the model that we have built. Okay, so that's the idea, that you use some random sample of the whole data to build a model, and then when any new person, any new data point that comes in, you can predict what would happen to that particular point with certain accuracy. Okay, so that's what the idea is. Now, does it remind, so those of you who have already studied quantitative methods in the first year, does it remind you of anything? It was also there in a recent assignment that you did. Have you done anything like this before?
Regression.
Okay, so we've already looked at one thing, and that was regression. So what does regression exactly do? It considers past data. It looks at certain variables, and it looks at how those variables relate to some output variable, right? So it's very similar to that. In machine learning, we're going to discuss some more algorithms that we can use to do this, to achieve the same thing. However, we'll discuss how this machine learning is going to be a bit different from what we used to do in that case, जो हमारा statistics का part था एक तरह से, regression models. This epsilon here that you see, this is basically known as the noise term. Any model that you build, of course, it's not going to be 100% accurate, right? No model can be 100% accurate because there's going to be natural variation. आप किसी की भी अगर आप इसी example को देखो, for example, you cannot predict someone's salary to the last cent, to the last rupee. That's not going to be possible. There are going to be many different factors. Maybe there are some things that affect the salary that you have not included in the model. It's always going to be the case. कि आप सारे possible factors, you cannot generally incorporate them because some of the factors are just not going to be quantifiable कि आप उनको model के अंदर include कर ही नहीं सकते, and some factors are not observable. आपको पता ही नहीं, आप उनको observe ही नहीं कर सकते किसी तरह से, right? So you cannot either quantify them or you cannot observe them, so you cannot include them in the model. So for that reason, there's always going to be some error in your prediction at the end. In regression, in the case of regression, we had a statistic in our output that was known as R square, जो आपको बताता था कि आपकी accuracy जो है वो कितनी अच्छी है. So we'll see some methods to evaluate that accuracy in machine learning as well. So this is the general idea of what we're going to do with machine learning. Now, we already said कि ये तो हम already कर चुके हैं, हमने पहले किया है भी regression में आप exactly यही चीज़ तो कर रहे होते हैं. So how is it anything new? So basically the idea is these are two different fields. So one was statistics, जिसके अंदर हम regression models build करते थे. We have only done some simple regression जिसमें हम dummy variables include करके देख लेते थे. We just introduced you to logistic regression, लेकिन उसमें बहुत ज़्यादा भी detail में नहीं गए थे. So basically the idea is we already have some way to build such prediction models. So since machine learning has exactly the same objective, how is it any different? So I'm going to list down some points that are going to show you how it differs from what we used to do in statistics. Now, statistics, of course, is a very old field. It's been there for centuries. आपके जब computers नहीं भी होते थे, it used to be there उससे पहले भी, and they used to do this calculation using pen and pencil, right? आप वो calculation जो सारे formulas आप use करते हो to build that regression model, you can actually do it manually as well. You don't need a computer for that necessarily. Machine learning, on the other hand, it's a very recent field. It only came about 30 to 40 years ago. जब जो है computational revolution एक तरह से आई थी, जब आपका processing power computers की बहुत ज़्यादा होगी और you had a lot of data. You were able to store a lot of data in your systems as well. आपके पास बहुत ज़्यादा data हो गया, and you were able to process that data very cheaply as well. And that's when learning from this data became feasible. Because so statistics is a very old field, machine learning is relatively recent, and then they come from some different schools of thought as well. Statistics is a field of mathematics, so that's a subfield of maths, and this machine learning is basically a subfield of computer science. Now, of course, in the recent years, let's say in the last decade or so, many people working in these fields are actually coming closer together in the sense case बहुत सारी चीजें आप जो statisticians करते हैं, they are actually moving towards doing all of that using computational power as well, or they're using a lot of things from this other computer science field there as well. And the other difference is that there's a difference in terms of their applicability in different uh, types of data sets. So for example, regression analysis या जो other techniques हैं statistics के अंदर वो आप apply कर सकते हो even on smaller data sets. So let's say you have a data set that's very small, about let's say a few hundred observations. So for example, हम जिस data पे काम कर रहे थे, it had जो stores का data था, it only had about 400 stores and just a few variables, about 6-7 variables. So regression and other statistical methods can generally work on smaller data sets when the number of variables is small. That's what low dimensional means here. Dimensions होते हैं number of the variables that you have. So statistical methods can work on low dimensional problems as well, and you also do not need very large data for that. Machine learning methods, on the other hand, work well when the data that you have is significant in terms of the number of observations you have. So you'll at least require, for example, thousands of observations, if not millions. And typically, the number of variables that you would be dealing with is also going to be much larger. There could be like hundreds of variables, which you would generally not use regression on, because regression में आप इतने ज़्यादा variables generally include नहीं करते. And then regression के अंदर we discussed earlier in our first course, regression बहुत ज़्यादा assumptions के ऊपर जो है वो चलता है. For example, you need to know कि आपका जो model है, is it going to be a linear model, is it going to be a quadratic model, what type of relationship is it going to be. So आप पहले वो assume करते हो and then you apply that method on your data. And there are a lot of other assumptions as well कि आपका data normally distributed होना चाहिए and some other statistical assumptions. Machine learning में you do not require a lot of assumptions. So it's more practical in that sense as well, that the results that you get are going to be more realistic. क्योंकि आपकी जो है कोई theoretical assumptions नहीं होंगी about your data, इतनी ज़्यादा नहीं होंगी. The only assumption that you are going to require still is okay, whatever is the process that you have used to get your current data. For example, आप कोई भी existing data use कर रहे हो to train your model, to build your model, whatever data you'll get in the future, that will also be obtained using the same method. So for example, abhi, if you have obtained the data using a random sample out of the whole data, in future, the method to get that data is going to be exactly the same. आपका randomly generated, randomly accessed data ही होगा, ठीक है? Randomly sampled data ही होगा. That's the only assumption that you are generally going to require. And it also varies in terms of how you come up with conclusions about these models. जो आपका regression models होते हैं, for example, उसमें if we remember, we used to have some sort of confidence intervals. Okay, अच्छा, if we are getting this prediction, we can be 95% or 90% sure that your final prediction is going to be between this and this value, right? So इस तरह की mathematically rigorous आपकी जो conclusions होती थी. In machine learning, on the other hand, the way you estimate the accuracy of your final model is going to be a bit different. So the way it happens here is that whatever amount of data you have, for example, let's say you have 1,000 observations, about 1,000 observations about some variables. What you would do is you would typically divide the data into multiple parts. You will train your model on one part, और फिर आप उसको test करते हैं on the other part to figure out कि वो उसकी predictions कितनी accurate है. Right, so that's generally how it works. We'll look at it in detail in the next few classes, but this is just the overview of what's going to happen there. So right, so these are some ways in which machine learning differs from statistics. Now, what do we want to do with machine learning? So, like with regression, there are going to be two main purposes, two main reasons we use machine learning for. So the first is prediction. Prediction is कि आपके पास कोई भी input variables हैं. Based on that, you want to predict something. For example, taking a recent example, you might want to consider the probability of, or let's say you want to predict whether a particular person has um, uh, coronavirus or not. So how would you go about doing that? You could look at the data set from the last 3 months. You could look at people who were tested positive by COVID-19 and what types of symptoms they had. So let's say there's a list of 20 different symptoms that are possible. You would have information about each of those symptoms के वो for each person who was tested, whether positive or negative, उनमें वो कौन से symptoms थे और अगर वो थे वो कितने severe थे. And then based on that, you could build a model, and with any new person that comes in, you can get information about those symptoms, उनमें हैं या नहीं है, वो कितने ज़्यादा severe हैं, and you can predict, sort of predict के वो उनको वो उनको कोरोना है या नहीं है, right? So that's one thing you can do. So in addition to the formal testing that is happening, this is another way to basically predict this thing. But of course, since the data right now may not be as so the amount of data that we have may not be as large. These prediction models are not working as well right now, but maybe when we have uh, well-structured data and large amount of data, this might work very well as well. But in terms of how the test itself works, that itself works on the same similar principles as well. जो भी आपका sample लेते हैं, they basically test on different variables or whatever they are कि वो उस sample के अंदर वो जो substances हैं जो भी वो test कर रहे हैं वो exist करते हैं कि नहीं, and based on that they predict whether this person has the virus or not. So even if they say somebody is positive, that's still going to be with certain amount of accuracy. For example, the current tests, I think they are about 70 to 80% accurate from what I've read. So again, in terms of any prediction, you're still going to have some sort of an error rate. So in this case, you can see some examples here as well. So you can detect cancer from blood samples. For example, blood samples लेते हो, you have your previous data कि किन type of blood sample में आपकी cancer की probability ज़्यादा होती है, and based on that you can make a prediction for a new person who is tested. Another example that is used very widely is to detect frauds in different kinds of industries. You can do that in insurance industries to test whether a person who has filed a claim, whether that's a genuine case or not, and you can test for that using the data that you have in the past, and then you can decide कि अच्छा हमें इसको further investigate करना चाहिए या नहीं करना चाहिए. So the first purpose is you want to predict something. So based on whatever inputs you have, you want to predict whether uh, predict either the numerical value of an output, या फिर in terms of a yes or no, a binary outcome के वो exist करता है इसके अंदर या नहीं करता. So that's the first thing. आप predict करना चाहते हैं using some sort of independent variables. The other thing is you want to draw some sort of inference, and that basically means कि आपके पास कुछ independent variables हैं, and you want to see how they affect your dependent variables. So for example, you could build a model that predicts sales, for example, based on a lot of different factors. Your sales could be affected by the price, by uh, your advertisement, by your marketing, and a lot of other stuff as well. So let's say you have built a model that predicts sales. Now inference could be कि जो भी आपने independent variables use किए हैं वो कितना इफेक्ट करते हैं आपके डिपेंडेंट वेरिएबल को. सो फॉर एग्जांपल, इफ यू हैव बिल्ट a prediction model for sales, one point of inference could be कि आपकी marketing जो है वो कितना affect करती है sales को, right? Similarly, let's say you've built a model that predicts life expectancy कि आप कितने years जो है based on a lot of different variables, um, how can you predict how long a person is going to live? And then what you can do is, for each of the independent variables that you have used in that model, you can actually draw an inference कि वो कितना affect करता है आपकी life expectancy. For example, one factor that you would consider in a prediction model for life expectancy would be smoking. And the inference could be कि आप देखना चाहते हो कि smoking कितना affect करती है आपकी life expectancy को, right? As compared to the other independent variables that you have used. Now, regression के केस में क्या होता था? You knew exactly कि आपका जो है functional form जो है वो relationship की वो क्या होगी. You knew whether it was a linear model, whether it's going to be a quadratic model, whether it's going to be a logarithmic model. तो उस केस के अंदर you know exactly how much each independent variable is affecting your dependent variable, right? In machine learning, that's typically not going to be the case. आपको exact वो functional form नहीं पता होगी. So essentially हो ये रहा होगा कि you'll be inputting some variables in some sort of a black box, and it'll be giving you some sort of an output. Right? आपको एक output दे देगा उन inputs के ऊपर. But you would not know exactly what is happening inside that black box. Okay, so generally for prediction, it's going to work well because all you're interested in is your final output based on your independent variables. However, for inference, it's not always going to work well. इसमें जो आपकी functional form है आपकी जो model की, that has to be known. It cannot be a black box in this case. Inference के लिए आपको पता होना चाहिए आपके exact function किस तरह से work करे. So a lot of the machine learning models that we'll be working with, they are only going to be useful for prediction. They're only going to be very few of them जो जिनमें आप inference भी कर सकते हैं साथ. Right? So does this make sense? The difference between prediction and inference. Any questions in this?
एक्सक्यूज मी सर,
Yes, Talha.
अगर मैं सही समझाऊं तो प्रिडिक्शन आपने टर्म दी है रिग्रेशन के आउटपुट को और इन्फेरेंस दी है मशीन लर्निंग के आउटपुट को, या opposite है ये?
No. Okay. Anyone who would like to answer that?
Sir, prediction is the output of the model और inference है हर variable का individual impact.
Okay, yes. So let's look at this thing here. Yeah, okay, I cannot highlight it for some reason. अच्छा, यहाँ पे देखिए जो नीचे आपको ये function नजर आ रहे हैं. So y is an output here, and how do you get this output? You basically apply some function on these independent variables x1, x2, x3, and for example, हमारे salary के case में x1 could be education, x2 could be experience, x3 could be something else, and so on. ये सारे आपके independent variables, right? Prediction is कि आपके पास एक नया student आता है who is just going to graduate this year. And you know his education, you know his experience. In that case, it's going to be 0. Of course, it's a fresh graduate. You know some other information about the person जो आपने model के अंदर use किया, for example, their nationality, their gender, their ethnicity, and things like that. Their academic performance, their GPA, जो भी सारी आपने चीजें model के अंदर include की हैं. Based on that, your model will give you some output for the salary. ये आपकी prediction होगी जो आपको output मिली है उस model से. So this y is going to be your prediction. जो आपको वो सारी values input करके जो result मिलेगा, that's going to be your prediction. Inference, on the other hand, means that you want to see how each of these variables on the right side, x1, x2, x3, is affecting your output individually. For example, education का कितना इम्पैक्ट होता है ऑन सैलरी, एक्सपीरियंस का कितना इम्पैक्ट होता है ऑन सैलरी, आपकी एथनिसिटी का कितना इम्पैक्ट होता है ऑन योर सैलरी, थिंग्स लाइक दैट. दिस इज कॉल्ड इन्फ्लुएंस. इज दैट क्लियर, तलहा?
सर यस सर, तो ये मशीन लर्निंग के साथ अलाइन करता है क्योंकि ये ब्लैक बॉक्स भी है और फिर हम इन्फेरेंस भी कर पा रहे हैं इससे.
Yes, so that's what I'm saying, that almost all of the machine learning models, most of the machine learning models are going to be black boxes, जिसमें आपको नहीं पता होगा exactly functional form क्या है, उसमें आप inference नहीं कर सकते, right? But there's some methods जिसमें you will still be do some sort of an inference, but they're going to be few, but the number of those types of models is going to be less as compared to those black boxes. So there do exist some models जिनमें ये black box नहीं भी होता.
All right sir, thank you.
All right. So now let's see how does this learning even happen. So for now, what I want you to do is I want you to just focus on, so let me try the highlighter and see if it works. I want you to focus on only this part for now. In fact, this part. So think about this. What I have here is I have these three variables, x1, x2, x3, and I have a dependent variable, that is the y variable. Okay, so let's consider this anything. So for example, आप predict कर रहे हो whether yeah, so let's say the chance of a person having a heart attack in the next 5 years, right? So this y is the outcome. So let's say if the person will have a heart attack in the next 5 years, तो यहाँ पे टिक होएगा. If the person won't have a heart attack in the next 5 years, यहाँ पे ये cross होएगा यहाँ पे, ठीक है? So yes or no. And your inputs could be, let's say, whether they exercise or not, some information. X2 could be, let's say, some information about their diet. X3 could be, let's say, whether they smoke or not. I'm not sure whether smoking has any impact on that. But let's say you have these three variables here, right? So you have information now. So first of all, there are 8 different possibilities, right? Each of these 3 variables is a binary variable. आपके पास x1 की भी 2 possibilities हैं, 0 और 1, x2 की भी 2 possibilities हैं, 0 और 1, x3 की भी 2 possibilities हैं, 0 और 1, right? It can either be 0 or 1. तो total आपके पास possible cases कितने हो जाएंगे? 2 multiplied by 2 multiplied by 2. आपके पास total 8 cases हैं अगर आप यहाँ पे देखें. The number of rows you have 8 possible cases. या तो सारे zeros होंगे, एक 1 हो जाएगा, उसमें last वाला let's say दरमियान वाला 1 हो जाए, and so on, or you could have all ones. So you have 8 different possibilities here. Now let's say you know about these 5 cases जो आपके पास ऊपर आ रहे हैं, right? So ऊपर जो 5 rows आ रही हैं, you already know these independent variables. कि जब ये कॉम्बिनेशन होता है तो आपको आउटपुट क्या मिलती है. सो फॉर एग्जांपल इफ पर्सन does if a person does not do exercise, but he does not have let's say any diet issues, he does not smoke, तो उनकी basis पर the output is that the person will not have a heart attack in the next 5 years, for example. So this is just an example. आपके पास 3 inputs थी, if all of them were zeros, तो यहाँ पे cross आ गया. If x3 was 1 and the first 2 were zeros, तो आपके पास यहाँ पे yes आ गया, and so on for the next 3 outcomes, right? Now, based on this information, can you say anything about these last 3 cases? कि ये हमें इन 5 cases में पता है कि result क्या आएगा. Can we say anything about these last 3 cases? Any ideas?
Yes sir.
हमें
Okay.
इन दोनों के इन वेरिएबल्स का आपस में रिलेशनशिप नहीं पता, तो आई डोंट थिंक हम विदाउट एनी इंफॉर्मेशन इस तरह कह सकते हैं.
Okay. Jalid, you wanted to say something else?
Sir, I think that you can see the individual relationships of each variable with y, तो वैसे भी y is डिपेंडेंट वेरिएबल और x इंडिपेंडेंट है, तो उसकी डायरेक्ट इम्पैक्ट तो y पे ही है ना। तो हम उस पे जिस तरह हम रिग्रेशन में इंडिविजुअल कांस्टेंट्स देखते थे, तो दिस वे मे बी वी कैन स्टडी इंडिविजुअल रिलेशनशिप्स और कंप्यूट कर सकते हैं हम इक्वेशंस।
Yeah, but how exactly would you study those individual relationships in this case without assuming anything? Regression में तो हमारी assumptions होती थी ना कि अच्छे linearly relate करते हैं एक दूसरे के साथ, हमें कुछ assume करते थे and then we would be able to say something about this relationship. तो यहाँ पे without any assumption, what can you do? तो आपको सिर्फ ये पहले 5 केसेस पता है, ये वांट टू से कि यहाँ पे ये 6th केस इसकी आउटपुट क्या होगी, 7th केस की आउटपुट क्या होगी, ये फाइनल केस की आउटपुट क्या होगी? हाउ कैन यू से दैट?
6 वाले में इसको हो जाएगा हार्ट अटैक।
ओके, 6th वाले में हार्ट अटैक हो जाएगा। ताहा ने अपनी वर्डिक्ट दे दी है। ओके, बट हाउ डू यू गेट टू दैट?
क्योंकि ऊपर वाले पैटर्न में देखा जाए तो जहाँ पे हमारा x1 और x3 0 है ना, वहाँ पे नहीं उसे हुआ हार्ट अटैक। जहाँ पे है नहीं, जहाँ पे हमारा ऊपर x3 हमारा 1 है, वहाँ पे उसको हार्ट अटैक हुआ है। जहाँ पे x1 1 है, वहाँ पे भी हुआ है। तो
ओके,
कह
सो
सकते हैं कि यहाँ भी x1 और x3 हमारा
बट फोर्थ केस में x3 1 है, वहां पे उसको नहीं हुआ। Yes, Jalid, you wanted to say something again?
नहीं सर, आई वाज जस्ट थिंकिंग कि मे बी वी कैन जस्ट हैव अब अगर तो रिलेशनशिप लीनियर है, व्हिच आई एम जस्ट अज्यूमिंग इट कुड बी डिफरेंट, देन वी कैन ड्रॉ अ बेस्ट फिट लाइन to get a response. Lekin I don't think that would apply to this.
अच्छा, इस केस में तो वैसे you cannot even have this assumption even does not make sense कि आपका linear relationship होगा, because these are binary variables, so these are not
Exactly.
continuous variables, तो आप उसमें linear relation तो हो भी नहीं सकता इसके अंदर। Usama, you want to say something?
सर आई थिंक इन सब में से S1 जो है वो बेहतर है।
इन सब में से x1 बेहतर है? अच्छा, f1 बेहतर है।
Sorry,
अच्छा,
F1,
फंक्शन
F1,
अच्छा,
yes.
फंक्शन f1 बेहतर है, बट व्हाट इज द रीजन फॉर दैट?
क्योंकि X1, X2 और X3 जो केसेस हैं वो उनमें X1 जब 1 है तो फिर वो आउटपुट पॉजिटिव है, और X2 जब 1 है फिर पॉजिटिव है, और X3 जब 1 है तो फिर पॉजिटिव है। यानी तीनों में से जब सिर्फ एक 1 है तो फिर पॉजिटिव आउटपुट है। तो उस हिसाब से तो F1 ही करेक्ट रिजल्ट दे रहा है, क्योंकि वो सब में नेगेटिव आउटपुट कह रहा है।
Okay, so all right, so in this particular case, you are saying that अगर यहाँ पे exactly एक 1 होगा, you're getting a yes. अगर उसके अलावा कोई केस है तो you're getting a no. But again, you only have 5 cases here, और ये नीचे वाले cases तो ऊपर कहीं पे भी नहीं आ रहे exactly, right? Again, you're assuming something. Again, you're basically assuming something कि इन 5 data points के अंदर मुझे लग रहा है कि जो exact जहाँ पे एक variable 1 होता है तो उसका result एक yes होता है, और अगर एक के अलावा the number of variables that are yes is other than 1, then we have a no here. But again, you're basically making that
Sir?
assumption. Yes, Azhar?
सर, ये जो थर्ड रो पे 0 1 0 पे पॉजिटिव है और उसके बाद 0 1 1 पे नेगेटिव है, इसका ये मतलब है इन दोनों जो x2 3 है इनका आपस में कोई रिलेशनशिप है। इसी तरह x1 और 2 का भी कोई रिलेशनशिप होगा, और पॉसिबली तीनों का इंटरडिपेंडेंट कोई रिलेशनशिप है। तो हम नेक्स्ट 3 को विदाउट हैविंग सम इंफॉर्मेशन कि आपस में कैसे फिट करें, हम प्रेडिक्ट नहीं कर सकते।
Yes. Acha. So I'm seeing some responses in the chat as well. So all of that, most of you are making sense based on this scenario कि अच्छा हो सकता है कि हमारी जब एक वैल्यू 1 है तो हमारे जो है वो yes आता हो, और otherwise जो है वो no आता हो. We have an odd number of ones, so we're getting yes. Okay, so that's a very good point. So Misbah is saying when we have an odd number of ones, we'll have a yes. So that's another type of inference you could have. In that case, Osama, this last case is also going to be a yes. So if we consider that scenario, कि अगर ये असल में it was like this कि जब भी आपके number of variables जो हैं जो 1 हैं वो odd हैं, for example यहाँ पे 1 है, यहाँ पे last case में 1 है, इस case में 1 है, तो यहाँ पे आपका yes होगा because you have one variable that is yes, तो उसकी output किया. तो यहाँ पे अगर आप नीचे वाली variables में देखें, we have all three variables that are ones here. तो इसकी output भी फिर yes होनी चाहिए because हम ये भी तो infer कर सकते थे वहां से कि जब भी odd number होएगा वो तो आपका result yes आएगा. So again, the point is without assuming anything further, we cannot say anything. So अगर आप यहाँ पे f1 से लेकर f8 तक ये सारे functions देखें on the right side, तो for the first 5 cases, these are giving us exactly the same result as these samples. ठीक है, तो हर function जो है वो आपको same result दे रहा है जो भी आपका original sample था. But ये जो unknown cases में we basically have all possible cases being represented by these 8 functions कि आपके पास क्या क्या possibilities हो सकती हैं. These are all possible cases that could happen in terms of these 8 functions कि या तो सारे yes हो सकते थे या last 2 yes होते, first or last yes होते, and so on. You have all cases represented here. Now, unless we have any additional information, any additional assumption that some of you are making, we cannot really say anything about this. ये सारे cases जो हैं they're equally likely. F1 से लेकर F8 तक anything is possible because the thing is you do have some information in the first 5 cases, but each of the 6th, 7th and 8th cases is a different case that's not exactly represented in the first 5 cases. तो अगर आपके पास 100 for example दोबारा आ जाता, then you would say okay it's going to be a yes. लेकिन इन 3 cases में से तो कोई भी पहले नहीं आया, तो you cannot really say anything without making further assumptions. So that's the first thing you need to know, that if you were to use this deterministic perspective कि आपको exactly जो जिस तरह के data points पहले आपके data के अंदर आ चुके हैं, वही data अगर दोबारा आए तो तब तो आप कर सकते हैं उसको predict. अगर उससे different कुछ आए तो आप exactly उस तरह से जो है predict नहीं कर सकते unless you make some further assumptions. So what we need to do is we need to define कि वो कौन सी assumptions हैं that we are going to have in machine learning. Yes, Talha?
सर इसे ओवरफिटिंग नहीं कहते अगर आप न्यू एग्जांपल्स को इवैल्यूएट ही नहीं कर पा रहे, प्रेडिक्ट ही नहीं कर पा रहे अगर
we'll come to that overfitting and underfitting as well, but right now the point was only that unless you make some sort of assumptions, you will not be able to say anything about the future. अभी किसी ने assumption ली कि यहाँ पे अगर जब exactly one case independent variables में 1 होता है तो वो yes आता है, that's an assumption. Another equally valid assumption would be कि जब ये odd number of ones होते हैं तब yes आता है. Both of them are possible. Similarly, there are many other scenarios as well जिसमें this might work. So all of these possibilities are actually equally likely unless we make some further assumptions. Okay, आपको कुछ assumptions जो हैं फिर भी लेनी पड़ेंगी. Without them, you cannot say anything about the future.
तो सर मशीन लर्निंग इसमें फेल हो रही है क्या? इसमें हम ये कहेंगे मशीन लर्निंग से रिलेटेड हमने कोई वर्डिक्ट दिया फिर?
नहीं, so मशीन लर्निंग का हम
अगर ऊपर वाली एग्जांपल्स नीचे वाली को नहीं कर रही.
No, so basically जो आप लोग apply कर रहे हैं, you are using some methodology from machine learning to infer that. अभी हम ये कह रहे हैं कि वो exactly जो आप assumptions use कर रहे हैं, वो किस तरह के assumption जो हैं आपकी machine learning के अंदर वो आप ले सकते हैं. वो हम अभी list down करेंगे कि ये assumption जो हैं आप ले रहे हैं, उसके बगैर आप prediction नहीं कर सकते. Right? So there are some assumptions that are necessary to predict that. The first assumption is जो मैंने पहले भी briefly mention की, that is that whatever data that you're using, whatever is the data that you're using to build your model, it should be drawn randomly from the overall data that you have. So again, let's consider that example. In fact, let's say हम ये वाली example लेते हैं. Let's consider the death rate, for example, from corona right now. So अगर आप जो है death rate predict करते हैं, death probability predict करते हैं for the whole world, and the data that you use for that is only, let's say, from Pakistan, that is not going to be a valid model. Why? Because जो overall global population है, उसकी distribution is very different from what we have in Pakistan. So in Pakistan, maybe the death rate is, the death probability might be a bit lower from the other countries because we have a larger population of young people here. So अगर आपने globally एक percentage, let's say, estimate करनी है, you have to use a representative sample from the whole world. तो आप सिर्फ ये नहीं कर सकते कि आप जो है एक specific जगह का data ले लें, उसकी base पर आप पूरे जो है पूरे world population के बारे में कुछ infer कर लें. So that's the first assumption, that whatever is the data that we're using, it should be sampled randomly from the overall data. Take a random sampling honi chahiye. And similarly, there's another thing that implies from that, and that is कि जो future में आप prediction कर रहे होंगे, वो जो future data है, that should also come randomly using the same rules as you were using for your original data. So for example, let's say वो salary वाली prediction देखें, तो अगर आपने model build किया है to predict the salary of people, और उसमें the distribution जो आपने random sample लिया था, उसमें males और females की distribution is about, let's say, 50-50. ठीक है, उसमें almost 50% of the data points that you have are males and 50% are females. And जो future में आप prediction कर रहे हैं, let's say all of that prediction data is of one particular gender. ठीक है, तो उस केस के अंदर it will not work as well. तो second assumption क्या है, जो आपकी original sample जिस तरह से randomly generate किया हुआ है, आपका future data जिसके ऊपर आप predict कर रहे होंगे, it should be sampled using the same method, exactly the same method जिसकी base पर आपका original data था. ठीक है, that's आप ये first और second assumption को एक तरह से combine भी कर सकते हैं to make a single assumption, and that is कि आपका current data that you're using for training your model and your future data, both of them should be drawn independently, drawn randomly from the overall data. अगर आप इसको yeah, in fact I think that makes it clear. The third assumption is that the function f जो आपने learn करना है, जो आपने for example ऊपर देखा था कि independent variables और dependent variable को जो function connect करता है, that function, even though we are not assuming very strict things like linear, quadratic, there should be some minimal requirements for that. ठीक है, ये बिल्कुल completely arbitrary नहीं होना चाहिए. It should not be like random zigzag lines. It cannot be like that. So इसमें कुछ certain assumptions फिर भी होंगे. And the first is that the function should be smooth. स्मूथ फंक्शंस का तो आपको सबको आइडिया होगा. So for example, a function, so let me try if it works here. Comment. Okay, so let me try if it works. So for example, you could have something like this. This is a smooth function. Okay, it's not drawing for some reason. Let me quickly check. There's the color. Okay, any idea how I can change the color of this pencil? Okay, comment format. It might be here. Okay, so let's say you have a line like this. Again, it's not working. Okay, so okay, so for example, this looks like a smooth function. Now, if you have something like this is not a smooth function because it has some corners. Or you could also not have something like this, that, for example, this is a wiggly function. This it should not be like this. So smooth hona chahiye function. It could have as many turns as you want. That's totally fine. लेकिन इसमें इस तरह से corners नहीं होने चाहिए. It should be fairly smooth. That's the first assumption. Whatever type of function it is, वो मैटर नहीं करता. आपने कोई assumption start में नहीं लेनी कि linear function है, quadratic है, logarithmic है, or any other function. You're not taking any such assumption initially. ठीक है? लेकिन there's a minimum requirement, and that is that the function has to be smooth at least. The second thing is that if you have similar predictors, आपके जो आप यूज कर रहे हैं, जो आपके explanatory variables हैं, उनकी values अगर आपकी डेटा के अंदर similar हैं, तो जो उनकी outcomes होंगी, they're also going to be similar. So now this is an assumption that you guys were using while making those statements कि जो पिछली वाली जो आपकी स्लाइड थी, that if let's say one of these is ones, you get a yes. So that was using that assumption that the future is going to behave similarly to the past. So that was an assumption. Okay, without making this assumption, you cannot say anything for sure. Without making that assumption, you cannot say anything for sure. So that's a very important assumption that you need to keep in mind. कि ये जब आप ये कोई inference इस तरह से कर रहे होते हैं, that is still based on this assumption that future is going to behave similar to the past. और जो आपके similar explanatory variables हैं, अगर उनकी values same हैं या similar हैं, एक दूसरे के आसपास हैं, तो उनकी जो outcomes होंगी वो भी उस तरह से similar होंगी. So that's another way you define this a priori knowledge. So these are the three major assumptions that we're going to be using for machine learning, and then it's possible for us to learn something from our data using these assumptions.
Sir?
Yes, Dalit?
Sir, second point में वो stationarity का एक कुछ समझ नहीं आया कि rules किस type के हो सकते हैं when you're assuming past historical data and drawing some results.
Okay, so let's consider कि आप yeah, so let's say आपने एक prediction model build किया है that you are using to predict whether somebody would get a heart attack in the next 5 years. आपने कोई इस तरह का model build किया है. Now, the current data that you are using, let's say it's randomly selected from the whole country. आपने पाकिस्तान से randomly लोगों को select किया. लोगों को सैम्पल किया, उनका आपने डेटा को यूज करके यू बिल्ट अ मॉडल वेदर आपने उनको बेसिकली 5 years के लिए स्टडी किया, उनके 5 years पहले जो है वो कंडीशंस क्या क्या कंडीशंस थी, नेक्स्ट 5 years के अंदर यू सॉ के उनको हार्ट अटैक कोई हुआ या नहीं हुआ. बेस्ड ऑन दैट यू बिल्ट अ मॉडल जिसमें आपने ये प्रिडिक्ट किया कि बेस्ड ऑन योर करंट बेस्ड ऑन पर्सनस करंट कंडीशन उनको उसको नेक्स्ट 5 years में हार्ट अटैक का चांस है या नहीं है. नाउ लेट्स से जो आप प्रिडिक्ट करते हो ऑन एनी फ्यूचर डेटा, आप जो let's say you want to predict what will happen to 100 different people. अब वो जो आप predictions करते हो, you pick up somebody from the UK for example, ठीक है, आप उनके ऊपर ये predictions run करते हो. Now the data the data is not drawn according to the same rules in this case because जो आपकी UK की population they might have some inherent differences from what we see in Pakistan. Maybe उनके जो है genetic reasons हो सकती हैं for not getting or for getting a particular kind of disease. There could be the issue of pollution in the air. जो आपने अगर पाकिस्तान के लिए आप consider कर रहे थे, आपने data build आपने अगर पाकिस्तान के लिए किया था, तो आपने pollution को इस तरह से एक factor in नहीं किया, let's say, because let's say the pollution numbers are similar across the country. Let's assume तो UK में it's going to be very different. तो जो आप future data जिसके ऊपर predict कर रहे हो, it should be drawn using the same rules जिनकी बेस पर आपने मॉडल बिल्ड किया. ये नहीं हो सकता कि मॉडल आपने एक तरह के डेटा के ऊपर बिल्ड किया है और जो आप प्रिडिक्शन कर रहे हो वो आप बिल्कुल एक डिफरेंट टाइप ऑफ डेटा के ऊपर कर रहे हो. That's what it means. Is that clear, Jalid?
Yes, sir. Thank you so much.
Okay. So now there are going to be some other divisions or other categories of machine learning models. So we're going to discuss each of these different categories briefly, and then we'll end for today. So the first thing is आपके पास दो different types of machine learning models होते हैं. मतलब एक तरह की ये categorization आप करते हो that we have prediction algorithms and we have classification algorithms. ठीक है, prediction क्या होती है? Prediction में इस केस में by the way prediction को आप you also call regression. Regression it's not the same thing as that statistical regression. जो हम linear regression का मतलब नहीं है, इसको हम regression problem भी ये कहते हैं, regression machine learning model. इसका मतलब ये होता है कि जो आपका output variable है it has to be a numerical variable, right? So for example if you're predicting the price of a house, that's a numerical variable, एक number आप predict कर रहे हो, right? So that's called a prediction algorithm, a regression algorithm. A price of, let's say, IBM stock, your sales in the next week, all of these are examples of predictions of regression. दूसरी category जो है that's of classification. इसमें जो आपका output variable होता है it's going to be a categorical variable. It could be binary, it could be more than two possible outcomes. That would be categorical. So for example इसमें क्या हो सकता है, you have built a model that classifies an email as either spam or not spam. So ये आपके जो output है that's categorical. Then you have, let's say, another model that classifies whether a person has one type of cancer, whether the person has another type of cancer, or he or she has no cancer, right? And similarly, you have these other examples like whether a person would default or not, whether a team would win or not. So all of these are categorical outputs. So हम क्या prediction या regression वो case होएगा जहाँ पे हमारी output numerical है. Classification is that type of machine learning algorithm जहाँ पे आप उसको different categories में classify करते हो, whether that it could be yes or no, it could be different other categorical variables. अब classification के अंदर भी there are two different possibilities. One is nominal, जिसमें कोई order matter नहीं करता. For example, email spam है या नहीं spam, the order doesn't matter here. All of these cases that are listed down here, all of these are nominal variables. But you can also have ordinal outputs. For example, आपका based on different factors, I can possibly predict what is going to be your grade in that particular course. Now that's an ordinal variable because A is higher than B, B is higher than C, and so on. So उसमें even though these are different categories, लेकिन उसमें एक inherent order exist करता है, so that's an ordinal variable. So classification के अंदर further ये दो categories हो सकती हैं. Then there is another type of categorization you can do for machine learning models. So one is that you have a parametric model, and the other is you have a non-parametric model. You can think of it very similar to what we discussed before as a black box or a non-black box. So black box क्या आएगा? Black box would be that you do not know what is happening to the functional form of f, what is happening to the function itself. आपको उसका पता ही नहीं है कि exactly उसके अंदर क्या हो रहा है, right? And you cannot infer anything in that as well. आप जो है उनको relate नहीं कर सकते your independent variables with the dependent variable, ठीक है? So that's a non-parametric approach कि आप inference भी draw नहीं कर सकते, लेकिन generally in terms of prediction it's going to be more accurate because आपके पास ज़्यादा flexibility होती है that you do not have to follow some specific functional form. This is the non-parametric one. So when you do not have a black box and you know the exact specific functional form, for example, just in a regression case में, you know that it's a linear regression, it's another type of regression. तो वहाँ पे आपको functional form पता होती है. This is called a parametric approach. Parametric approach because parametric comes from parameters. Parameters हम explanatory variables को हम parameters भी कहते हैं. जो आपके independent variables होते हैं उनको हम parameters भी कहते हैं. ठीक है? नॉन पैरामेट्रिक जहाँ पे एक्सप्लेनेटरी वेरिएबल्स को आप रिलेट नहीं कर सकते इंडिविजुअली, उनको उनसे इन्फर नहीं कर सकते कि उनका इतना इफेक्ट है, इसलिए हम उनको नॉन पैरामेट्रिक अप्रोचेस कहते हैं. सो पैरामेट्रिक अप्रोच में क्या आएगा? यू हैव some information about the functional form, you know exactly how the output depends on the independent variables और हर एक का कितना कितना इफेक्ट हो रहा है on your output. इस केस के अंदर पैरामेट्रिक केस के अंदर you can also do inference in addition to prediction. लेकिन इसके अंदर even though आपको जो required data होता है वो इतना ज़्यादा नहीं होता. For example, regression के केस में you do not need a lot of data. You can do that with smaller data sets as well. Predictions are not going to be as accurate as you would get using machine learning models because parametric approaches are generally inflexible. अगर वो linear model है तो उसने एक straight line ही बनानी है. अगर quadratic model है वो सिर्फ उस quadratic curve को follow कर सकता है, उससे बाहर कुछ और form follow नहीं कर सकता. Non-parametric के अंदर it's much more flexible, so that it provides a better fit generally and gives better predictions. लेकिन to achieve that, you mostly require a large amount of data. You generally require thousands of data sets and in many cases, hundreds of thousands of data points to get good predictions. So this is another type of categorization you have in machine learning models. And then there's another type of categorization, and that is between supervised models and unsupervised models. अभी तक जो हम सारी discussion कर रहे थे, we were basically discussing only supervised learning models, and they're going to be more common as well. हम ज़्यादा इन्हीं को discuss कर रहे होंगे. But there's also another type of learning that's called unsupervised. So first of all, let's discuss what supervised learning means. Supervised learning में again, as we discussed in our examples, we have some sort of an output variable, some dependent variable. For example, we had sales as the dependent variable. We had whether a person would have cancer or not, or heart attack or not. That is the dependent variable. आपके पास कोई dependent variable होता है, and corresponding to that dependent variable, you have a range of independent variables in your data, और आप predict करना चाहते हैं your output, your dependent variable based on those predictors. तो आप supervise करते हैं based on your data के हर independent variable से combination पे, for example, आपको क्या output मिलती है, and how you can learn some patterns, how the machine learning model can learn some patterns from that data कि आपके किस तरह से independent variables relate करते हैं आपके dependent variable के साथ. Unsupervised learning, on the other hand, does not have any output variable as such. उसमें कोई outcome नहीं होती जो आपने predict करनी होती. उसमें आपके पास सिर्फ सारे जो हैं वो independent variables हैं in a sense. कोई भी उसमें आप prediction नहीं कर रहे. And the goal in this case, the objective in this case, and when you're doing unsupervised learning, is that you want to group your data into different parts. You might have heard of this thing called segmentation or cluster analysis. So this is what you can do using unsupervised learning. कि आपके पास, let's say, data है. For example, it's very widely used in customer segmentation or market segmentation. उसमें क्या होता है, you can group different types of customers. उसमें आप predict नहीं करना चाह रहे कुछ, but based on let's say their buying behaviors, you can let's say you run a retail store and you have data on the customers that come to your store. You can sort of cluster or segment those customers based on whether they're high spenders, whether they're medium spenders, whether they are low spend, whether they do not spend as much. You can segment the customers in different ways. This is one way to cluster, one way to segment. कि आप उनकी spending के base पर segment कर दें. You can also do this on some other variables, as we'll see later on. So that's the difference between supervised learning and unsupervised learning. Supervised learning में you have some output variable जिसको आप predict करना चाहते हैं. Unsupervised learning में you do not have any output variable. You only want to basically cluster your data, group your data into different sets. ठीक है? So we'll stop here. This is just a visualization of what different methods there are that exist. So if you look at this horizontal axis, you have whether whether they require numerical inputs, whether they require categorical inputs. Columns के अंदर, it's whether they are prediction algorithms, whether they are classification algorithms, and whether they are supervised or unsupervised on the right side. So these are all many different methods that exist. We will be discussing some of them that are in green here. So we'll be discussing KNN, SVMs. We'll see if we get time, but we might not be able to. We'll see. So we'll discuss KNN, we'll discuss naive Bayes, we'll discuss classification trees, regression trees. Of course, you would not understand it much right now. You'll only have an idea once we get into more details on that. So you can have a look at this. I'll also share the slides after the class. You can go through them again, and we're going to stop here. If you have any questions, you can ask, and if anybody wants to leave, they are free to leave now, because we are ending our class now. Okay, I'll just be taking questions now. Yes, Fatima. Fatima, you want to say something? Talha?
सर मुझे ये पूछना था कि ये नॉन पैरामीट्रिक और ये अनसुपरवाइज्ड एक ही चीज है?
No. Non-parametric is basically a type of supervised learning. So supervised learning के अंदर आप कह सकते हैं दो categories हैं, parametric and non-parametric. Parametric में you know the specific functional form. For example, regression case में आपको पता है कि वो linear है या कोई और model है. Non-parametric के अंदर आपको function नहीं पता होता, बस वो एक black box को use करके आप predict कर रहे हो. और पैरामीट्रिक के अंदर इट्स नॉट अ ब्लैक बॉक्स, यू नो द फंक्शन। तो ये दोनों सुपरवाइज्ड लर्निंग के टाइप्स हैं, राइट?
सर ये लास्ट में जो आपने समरी दी है, इनमें से आप एग्जांपल दे सकते हैं कि कौन सा पैरामीट्रिक है और कौन सा नॉन पैरामीट्रिक इनमें से?
कौन सा पैरामीट्रिक है, कौन सा नॉन पैरामीट्रिक है? सो दिस लीनियर रिग्रेशन, द लॉजिस्टिक रिग्रेशन, these are पैरामीट्रिक बिकॉज इसमें आपको फंक्शनल फॉर्म पता होती है, ठीक है? बाकी all of them are, yeah, all of the others are non-parametric.
राइट, ठीक है सर।
Okay, anyone else? Any other questions? Arham, yes.
सर मेरा एक पिछली क्लास से क्वेश्चन था जीजी प्लॉट के बारे में।
Okay.
सर मेरा क्वेश्चन ये था कि मुझे ये नहीं समझ आई अभी भी कि इसके अंदर जो हम डिफाइन करते हैं स्केल स्केल एक्स कंटिन्यूस या स्केल वाई डिस्क्रीट या जैसे मर्जी, इसका क्या पर्पस है और ये कब करते हैं?
अच्छा, जो हमने उसको यूज़ किया है वो बेसिकली आपके जो एक्सिस है ना, उनकी फॉर्मेटिंग को चेंज करने के लिए होता है जनरली। तो फॉर एग्जांपल आप ये स्केल फंक्शन जो है, स्केल एक्स की बात करें या स्केल वाई की बात करें, वो आप
हाँ
यूज़
जी।
करते हैं एक्स एक्सिस पे। आपने फॉर एग्जांपल लेबल चेंज करना है, उसके एक्स एक्सिस का टाइटल चेंज करना है, उसमें जो आपकी वो जो क्या कहते हैं उसको, जो नंबर्स आ रहे होते हैं, सो या सो एक्सेस, yeah, I'm forgetting what you call that, जो नीचे, so for example आपके पास x axis में it's a continuous variable, let's say आपके पास जो numbers हैं right now they are 0, 20, 40, जो आपका scale है basically 0, 20, 40, 60, 80 and so on, उसकी आप let's say breaks change कर सकते हैं। अभी अगर 20 का ब्रेक है आप उसको 10 पे कर सकते हैं, अब उसकी टोटल रेंज आप स्पेसिफाई कर सकते हैं, आपको 0 से लेकर 200 तक स्केल शो करना है, एंड थिंग्स लाइक दैट। सो दैट्स
नहीं,
व्हाट इट।
ये जो आप कह रहे हैं ब्रेक्स चेंज कर सकते हैं, ये मतलब ये आप मुझे ये लिमिट्स और ब्रेक्स की भी समझ नहीं आई थी अभी भी प्रॉपर्ली कि इसकी क्या मतलब ब्रेक्स चेंज कर सकते हैं।
अच्छा, फॉर एग्जांपल आपके पास नीचे जो ग्राफ है ना, ग्राफ में अभी आपके पास वैल्यूज शो हो रही हैं 0 से लेकर 1000 तक,
हाँ जी।
ठीक है? लेट्स से आप और 0 से लेकर 1000 तक ऐसे शो हो रही हैं कि वो पहले एक 0 का पॉइंट है, उसके बाद 0 के बाद 250 है, 250 के बाद 500 है, फिर 750 और फिर 1000 है,
हाँ
ठीक है?
जी।
लेट्स से आप इसको चेंज करना चाहते हैं, आप चाहते हैं कि मैं 0 से 1500 तक स्केल शो करूं,
अच्छा, ठीक हो गया।
ठीक है? और उसको मैं ब्रेक कर दूं 500 के गैप से, या लेट्स से 300 के गैप से इंस्टेड ऑफ 250, दैट्स व्हाट ब्रेक्स मींस, और
तो
दैट्स व्हाट
ये
वी डू।
मुझे ज़रा ये सीक्वेंस जो इसके अंदर हमने लिखा हुआ है कि ब्रेक्स इज इक्वल टू सीक्वेंस और फिर इसके बाद हमने 3 आर्ग्यूमेंट्स दी हुई है,
यस,
इसी ऑर्डर में ज़रा मतलब ये पहली आर्ग्यूमेंट हमारी स्टार्टिंग है
यस,
और ये जो जो हमारी मिडिल वाली है ये हमारी आखिरी वैल्यू होगी,
यस,
तो ये लास्ट वाली वैल्यू क्या है?
दैट इज द ब्रेक, कि आपको कितने, फॉर एग्जांपल 0, 0, 100, 0 फर्स्ट वैल्यू है, 100 या 1000 सेकंड वैल्यू है, और थर्ड
अच्छा,
वैल्यू अगर 50 है, इसका मतलब है कि 50 के ऊपर ब्रेक्स होंगे, तो 0, 50, 100, 150, 200, इस तरह से वो एक्सेस चलेगा।
ठीक है सर। एक आखिरी क्वेश्चन था कि आपने भी जो हमें कराया था उसके अंदर आपने एक दो जगह जिस तरह अगर हम प्राइस की बात कर रहे थे कंटिन्यूस वेरिएबल में, तो
यस,
उसी के अंदर आपने एक डॉलर साइन लगा के उसको ब्रैकेट्स में क्लोज किया था, तो इसका क्या मतलब था?
वो तो बस लेबल में मैंने लिखा था कि वो लेबल में क्लियर हो जाए कि प्राइस जो है उसका यूनिट क्या है, उसका और तो कोई मतलब नहीं था, तो
नहीं
लेबल।
मतलब वो आप अच्छा आप लेबल बदल रहे थे इस तरह उसका?
यस वो लेबल चेंज किया
ठीक
था,
हो गया।
बिल्कुल।
ठीक हो गया, ठीक है, यही पूछना था।
ओके, ओके, एनीवन एल्स?
Sir, we have a meeting.
Yes.
So,
I'll wait for some questions, and let's say after 5 minutes, we'll start our meeting when everybody else leaves. Yes, Aves. Aves, you've raised your hand.
सर मुझे आपसे पूछना था कि ये ब्लैक बॉक्स के बारे में बेसिकली।
ओके, क्या पूछना था?
सर आपने बात की थी कि पैरामेट्रिक में बेसिकली आपके पास फंक्शन होता है, आपके बेसिकली आपको पता होता है कि ये फंक्शन है, ये हम यूज़ करेंगे और स्मॉल डाटा सेट होता है मोस्टली। लेकिन जब नॉन पैरामेट्रिक अप्रोच होती है तो बड़े साइज का डाटा है, उसमें हम ब्लैक बॉक्स यूज़ करके हम प्रिडिक्शन कर रहे होते हैं। तो ब्लैक बॉक्स बेसिकली क्या है, ये मुझे नहीं आइडिया इसका।
नॉन पैरामीट्रिक अप्रोच का मतलब ये है कि जिस फंक्शन को यूज करके आपको आउटपुट मिल रही है ना, वो फंक्शन का आपको नहीं पता होता। बस आप इनपुट देते हैं फंक्शन को और आपको आउटपुट मिल जाती है, लेकिन आपको ये नहीं पता कि फंक्शन एग्जैक्टली वो क्या है, बिकॉज इट्स सो कॉम्प्लेक्स दैट यू कैन नॉट इंटरप्रेट इट इन एनी वे। ठीक है, अब वो फंक्शन क्योंकि आपको विजिबल नहीं है, या फंक्शन is not humanly understandable, that's why we call it a black box। के black box का मतलब है कि उस बॉक्स के अंदर जो फंक्शन है हमें नहीं पता कि उसके अंदर क्या हो रहा है। तो उसकी जो है आपने ब्लैक कोट किया हुआ है उसको, दैट यू कैन नॉट सी व्हाट इज हैपनिंग इनसाइड। दैट्स व्हाट इट मींस। बस एक टर्म है जो यूज होती है, इसका मतलब सिर्फ ये है कि जो फंक्शन आपकी इनपुट्स लेके आपको एक आउटपुट दे रहा है, आपको ये नहीं पता कि वो फंक्शन एग्जैक्टली क्या है, बस आपको आउटपुट मिल रही है और वो उसकी एक्यूरेसी अच्छी है, दैट्स ऑल यू नो।
ओके, थैंक यू सर।
ओके, okay, anyone else? Okay, I'll wait for a couple of minutes and then we'll end. I also have a meeting with a group after this. I'll just wait for a couple of minutes. So Aisha, Usama, Awais, and Umar, I'm going to share with you a meeting ID on our WhatsApp group. So please join that meeting. Maybe I'm ending this meeting. You can join
okay,
that.
sir.
Okay, yes, I'll upload slides as well. I'll do that, yeah. Okay, so Azhar, okay, so I actually missed some of the questions here. On random for future data set, then parametric and classification are supervised learning.